Question number 4 tells us we have block X and Y tied together by a rope. So I'm going to pause right there and just think through this situation before I let it get too complicated. They're tied together by a rope. So if they're tied together by the rope and they are held, they will slide down the inclined plane. So now I might ask myself, if there were no rope, how would it be different? What happens? Well, the reason that Y slides down the plane is because gravity is pulling it downward. Gravity is pulling it downward and the inclined plane deflects it. So both X and Y are going to accelerate down the plane, not because they're tied to each other, but because gravity is pulling them down, and gravity acts on all bodies with the same amount, whether it's straight down or at an angle and all of that. So we just have an understanding of what's going on here. We have these two blocks. These two blocks, they're tied together. They're going to accelerate down the plane because of gravity. And the fact that they're tied together may be irrelevant to this situation. So we say the system, next, the system containing block X and blocks Y is released from rest on a ramp. So we put in V0 equals 0, which we'd expect, and they are actually defining the system for us. That's nice. The system of these two is released. Block Y has a smaller mass than block X, which we already know that the fact that those masses are different from each other, or whatever they are, is irrelevant to the acceleration they experience. They might want us to be tricked into thinking that M will catch up to the smaller M because it's got a bigger mass, but we know gravity doesn't cause them to accelerate at different rates. They accelerate at the same rates. All right, so we've taken that into account. Which of the following claims is correct regarding the momentum of the system containing only block X? All right, so now if we define that system differently to be only block X, the momentum of that system, well, in the beginning, we know the law of conservation of momentum says, this is for X, that the initial momentum will equal the final momentum unless an outside or external force. Well, what we see in the beginning, the momentum is 0, but the momentum increases over time. So that must mean there is an outside force. And if the system is X, must be a force outside that system that's causing it. And that force we know to be the force of gravity. So that system appears to be open. It's definitely not closed. So just getting to that point tells us, it gets us down to two choices. So we know that first part. And the system that contains block X and block Y, so that's the yellow system. Well, the yellow system, the block Y is also being, if we considered it an individual system, which we weren't asked to do, but if we were, we would say the same thing about block Y, that it's an open system because gravity is acting on it. Therefore, the open system that is X and Y must be an open system because that whole system is accelerating because of gravity. And so we definitely know that both are not, the system of both blocks is not a closed system. It is open for the same reason that it is for X and it is for Y individually.